Here's our specification. A customer has a savings account and a loan account. Each account has a type, savings or loan, and a balance. The initial balance is read from the user. The menu provides these options: deposit into savings, withdraw from savings, transfer from savings to loan, viewing the balance of all accounts, and exit. So, quick look at the sample IO. We initially put in our balance for the savings, then the loan. We can show a little help menu. We deposit $50 into the account. So now when we show, we have $1,050 in the savings. Then we transfer $100. So now the savings account has gone down 100 and the loan account has gone up 100. We withdraw $22, so $950 went to $928, and then we exit. Okay. So how we're going to break this down is we're going to create this little table here, which is just another way of writing the class diagram, but now we can edit it. The first thing we're going to do is we're going to come up with the fields. So that's the data for the customer and the account. So looking at the specification, each account has a type and a balance. So the type could be savings or loan, so that's probably a string, and the balance is going to be, well, it's going to be a double, isn't it? So string type and double balance. Next, look at the customer. And the customer just has a savings account and a loan account. That's all it has. So it has an account of savings account and also an account, loan account. Next is the constructors. So I'm going to do the account constructor first. And what we're looking here is trying to convert the specification into those three constructor patterns. So it says the initial balance is read from the user. Okay, so balance is that read from the user pattern. But what about the type? It doesn't say how we set the type. And because type changes, so it could be savings or loan, that means the type must be from parameters. So the constructor for this will be account string type. The constructor for the account, so for the customer, it doesn't say anything, therefore creating a savings and loan account is probably going to be from literals. So the account constructor, so the customer constructor, sorry, is just blank. Next we can come up with the goals. So there's going to be a menu, and then the menu has 4 separate goals. So to do our menu here, then we have our deposit, withdraw, transfer, and show. A key difference between this demo and the lecture demo is that we have 2 accounts here. Because we have 2 accounts, we can't put the menu in the account. If we put the menu in the account, then we can only access one of those accounts. Okay? Because some of our methods here need access to 2 accounts, the menu must go in the customer. So here we can put the functions. So the menu goal relates to the customer use method, and it doesn't have anything in the account. The deposit, there'd be a method called deposit in the customer, and then that method could tell the account how much, the amount to deposit into that account. Same with withdrawing. Transferring, though, is a little bit different. Somehow we need these 2 accounts to talk to each other, right? Transfer, we need to take money out of one account and put it into the other account. One way we can do that is something like this. we give it a target account to transfer to, like that. I'll explain how this works more when we implement it. And lastly, show. We have a method called show. And the associated method with that is the toString override. Alright, let's move on to implementing. The first thing we're going to do is implement the fields for both accounts. Both classes. Starting with the account and then the customer. So the account has two fields, a type and a balance. So these are going to be private. Private string type, private double balance. Next, I will do the customer fields. Private account, same as account, and a private account, loan account. At this point, you should be uploading your code to Plate, and Plate will tell you if it's correct or not. Next, we do our constructors. So remember, the account constructor initializes the type from a parameter, and then initializes the balance from the user. So constructors look something like this. Public, then the name of the class, so account. Then we have our parameters. And we'll set type to this type. We can't just go type equals type here, because both of these types actually refer to this type. We want to refer to that type, don't we? And the way we do that is we can type this dot, and that means this, so the account's type equals that type, and that'll work. Next, we want to read the balance, so balance equals read balance, and we can create another private method to read the balance. How does a read balance look? Let's have a look. So it says initial and then the type and then balance. Initial. So what I'll do here is I'll just add our type that we've just got into that prompt. So this will say initial savings balance, and then it'll also say initial loan balance. Okay, so that's that constructor done. Now let's go on to the account constructor. Here we're just initializing from literals. So our savings account will be a new account. That's how you create them. Same with the loan account. Because our account needs a type, we must give it one. So the type of the savings account is savings, and the type of loan is loan. Let's do a public static void main. And this will be our only static method in the entire program from now on. And its entire purpose will just be to create the customer. So if I run this now, should prompt us with a savings account and then the loan. So that's all working, that's nice. Let's do the next part, which is the goals. So the menu goal. So this goes into the customer. And this will be a public method called use. In here, we're going to have a merged read loop and a switch statement. X, I think, was the end value. Let me do the read choice method. Oops, so that's our prompt. And we're printing in.next char. We're just reading a character. Okay, so we're reading the character in the loop. And then what we do is we do a switch on this choice. So this is kind of like a special big if-else statement, and allows us to really easily write different code for different individual characters here. So when we see a D, we'll do the deposit method. When we see a W, we'll do the withdraw method. When we see a T, we'll do the transfer, and etc. In the case that it was none of the above, we can provide a default case. So that's like the else of an if-else. And this will just be our help menu. One curiosity with switch statements is code will continue running. So if we put in a D, it will run the deposit method, and then what we'll actually do is we'll run the withdraw method, the transfer, it'll keep going down. So the way we stop this is we put a break. And that will correctly run the deposit method, break, which means it goes at the end of the switch, then it reads the next choice. So that's what we want. Okay, so what I'll do is I'll just put blank methods for all these 5 here. These can be private. I will just quickly implement the help method. Which I have saved here. And that looks good. We should be able to test this. And it will first prompt us for the savings, then the loan. We have forgotten to actually use the menu. So in our main, we need to call new customer, then use that customer straight away. Okay, so none of these options do anything right now, but the help menu should work, and exit should also work. There we go. Cool. Alright, so once you've done that, we can start bashing out the goals. I usually do the show goal first. Reason is it's just a really easy way to test the other goals, right? Because if you can't see what you're doing to your classes when running it, then how can you debug it? So the show method is the best way to start with that. So for our show method, we just want to print out the savings and the loan account. So I'm going to use just system.println, and I'm just going to put in the savings account and the loan account. If I run this right now, what happens is it prints out the name and then a memory address, so where Java is storing that account. We can change what it prints out by implementing the toString method over the account. So the toString method is a public method which returns a string, and you should put the @override annotation on it. And here we can return what that account is as a string. So we want to return savings account has $, and then this is the formatted pattern, isn't it? So instead of savings account, we actually want to put type plus, because this could be savings or loan. And then here we'll do plus the formatted pattern for balance. So I'll quickly do the formatted, private string formatted for some value. And how we format a number in Java is we use something called a decimal format. And that's inside java.text. So you must import it at the top. So I'll create a new decimal format. In here we put our format string. So something like should do. And this means always put in at least two decimal places and one character before the decimal place, and then optionally put the rest in with a comma. So that's perfect for what we need. And we're just hoping no one has over $1 million. So let's format that with value. And I need to return this. Okay. So let's test that. And there we go. So showing now works. So now we can test all the other methods, and we can just quickly see what the values are with show. So that's why I do show first. So let's do the deposit method. So here we are reading an amount to deposit, and then we are depositing it. So something like that. And what I'm going to do is I'm going to use my savings account. I'm going to call the deposit method on the savings account with that value. So let's do a double read amount to deposit. And that looks something like that. Okay, and now we need to make the deposit method inside the account. Public void deposit. We're taking in an amount to deposit, and we're just going to add it onto the balance. So balance plus equals amount. Okay. So we can quickly test this. So savings account is $1,000. We then deposit $50, and now a savings account has $1,050. So that's all working. Let's do the same for withdrawing. So same steps. We read an amount to withdraw, and then we withdraw it. These two read methods are extremely similar. They only differ in this little prompt here, don't they? So we can actually combine them. What I'm going to do is I'm going to combine them by making the code give us a prompt. So amount to plus prompt, like that. And now we can give the prompt to that method. Okay, let's make the withdraw method in the account. Which just does the inverse of depositing. Cool. And then we can do the transfer. So transfer, again, we're reading an amount to transfer. And then what we're doing is we're taking money from savings and putting it into loan. We could do something like this. Withdraw the amount from savings account and then our loan account. We could deposit that amount in like that. We could do it like that. The problem with that is now we've kind of added some logic into the customer where really the logic should be inside the account. Okay, so let's push the transfer code to the account. So instead I'm going to go savings account, transfer to the loan account with that amount. So let's do this transfer to method. Transfer to a target account with the amount. So transfer to, again, has two steps. First step is to take out the amount from the current account, and then we want to transfer it to the target account. So we want to kind of deposit into that account. We can actually just go target or balance, plus equals amount. When I first saw this, this usage here, I was a bit confused because you might think, okay, balance is private. So I understand how we can modify our own balance, but how can we modify some other account's balance, right? It's private. The thing you have to remember is private means private to the class, okay? It's all encapsulated within the class, but what that means is that the account class can modify not only its own account, but any account. So that's why this is legal. Okay, so that all works. What if we transfer $750 right now? That still works. We shouldn't be able to transfer more money than our savings account has. So let's just add in a bit of code to prevent this from happening. What I'm going to do is I'm going to introduce a method into our account that tells us whether or not we have the amount of money. So I'm going to just call it has double amount, and this should return true or false whether the account has that money. So return true if our balance is greater than or equal to the amount. And then we can use this method in our withdraw and transfer methods in the customer. So if you do everything correctly, it should just read just like English. If the savings account has the amount, then we can withdraw it. Otherwise, print something like not enough money. And we can do the same for transfer. So we transfer $2,000, not enough money, but we can transfer $500, and we still can't transfer 501 cents. Won't work. Okay.